Hello, welcome back. In this segment, I'm going to show you an interesting behavior when you're comparing, say, for example, a character type with a short type. This can be easily generalized to all other types, but let's take character and short as an example. You are seeing here C being declared as a character, S being declared as short. The program returns 1 if C is less than S, otherwise it returns 0. Okay, but C and S are two different types. The natural question is, will C be converted to S or S be converted to C type? Okay. It's not that straightforward to right away answer that question. It becomes much more easier to answer if you look at the assembly code. Okay, so the code we are seeing is one-liner, C less than S, right? C is character type, S is the short type. So the program takes two inputs, C and S, and load it into GDB and disassemble the function compare. I'll highlight the most important ones. If you remember the syntax of the code, right? The program had two arguments, C and S. So C is compared with S. C is a character type. S is a short type. Okay. And C was the first argument and S was the second argument to the function, compare function. Okay, where is C and S in this assembly? As you can see, move 8 plus EBB. 8 plus EBB means the first argument. So the EDX will have C. EDX will be C at this point. EAX will have 12 plus EBB, which is the second argument. So EAX will be second argument is yes, right? Yeah. But then remember, our EDX is the first argument, which is a character type. So we need to only take only one byte, not all the 4 bytes. That's the reason for the next instruction, move DL. DL means the least significant byte of the EDX register is moved to EBB minus 4. So EBB minus 4 has the value C, just 1 byte. Okay. EBB minus 8 has the value AX. AX means the 16 least significant bits of EAX. Okay, which is nothing but yes. All right, at this point we have yes. Okay, now we are doing move SBW. What it means is we are doing a signed byte extension to a word type. Word means, in this case, whenever you see move SBW, W means a word. So we are moving a signed byte. Byte means 8 bits to a word which is 16 bits. All right, so we are taking EBB minus 4, which is nothing but C, but C itself is just 1 byte. Therefore, we are extending it to 2 bytes. Okay, so AX, that's the reason why we are putting into AX. AX is 2 bytes. Okay, so what we are doing here is that we are essentially taking character C and sign bit extension. We talked about moves BW in previous segments. It's called signed bit extension. So we are essentially converting the C into a short type. Yeah. So this AX is anything but the sort of, you can imagine at this point, right? Your AX is nothing but, AX means 2 bytes. So it's nothing but you're casting your C to a short type. That's a better way to imagine what's going on. Okay. And then we're comparing EBB minus 8, which is nothing but yes, right? This is EBB minus 8 is yes, according to the notes here. So we're comparing yes with C here in this comparison statement. So we're doing compare, okay, yes, and C. So if C is less than yes, we are setting the least significant byte of EAX, which means either we are setting it with 1 or 0. That is the set L doing. And then we do a sign, we do 0-bit extension here. That's the reason why you see Z here, move ZBL. That means you'll have either 1 or 0, depending on the comparison operation. Okay, if the comparison operation succeeds, meaning C is less than S, AL will be 1, otherwise AL will be set to 0. Okay, that's basically it. So the summary is that if you're comparing a small type with a large type, the small type will be extended to a large type. That's the reason I put, you see here, sort of C. C was originally declared as character. The under the hood behavior is treating C as if it was a short type. Okay, so you're allowed to compare a small type with a large type. Automatically, the small type will be promoted to a large type. Therefore, there's no loss of information, either through signed bit extension for the signed case. For unsigned case, it will be like 0-bit extension. And there's no problem. You can compare a small type with large type. That's all. Thank you very much for your attention.